anything happens with YouTube. And then I'm
Okay.
just gonna make a short introduction. And I'll pass it to Juan, and then we'll introduce Shajay as well. So you tell us, Marta, when you're ready.
Mhm. We are online.
Okay, perfect. Okay, so good evening, everyone. I would like to thank you all for being here tonight. Welcome to the second lecture of the series we have organized as part of the Design Research Workshop that I have the pleasure to lead at the SEO University San Pablo in Madrid. The Design Research Workshop is one-week workshop exploring computational design tectonics in architecture through procedural design methodologies and design experimentation. Inspired by form-finding strategies from the pioneers of computational design and novel digital tectonics developed over the last 20 years, students will explore strategies for a serpentine pavilion design proposal. As Zaha Hadid used to say, there is no end to experimentation. If you are interested, we'll be sharing the results and upcoming lectures on Instagram. And I would like to express my gratitude to Juan Antonio and Marta from CEO for organizing this event, and Shajay Bhooshan to accept our invitation to share his experience and knowledge with everyone here tonight. I'm going to pass it to Juan Antonio from CEO.
So hi everyone, my name is Juan Antonio Fuentes. It's an honor for me to be here representing CEO University for this workshop. And first of all, I would like to thank everyone who attended Pablo's lecture yesterday, which was truly inspiring, giving an insight to Zaha's DNA. And I know that many of you are here with us today for this second lecture. It is so satisfying for all of us to see how good this initiative is being taken. So I want to express my gratitude to Marta López Gorria and Alejandro García Gadea for both being actively involved in this initiative and for believing in me since the very first moment I proposed you this initiative. I hope you all enjoy this amazing lecture, and especially thank you so much to Shajay for giving us part of your time. And it's a real pleasure and a really privilege having you here tonight. So thank you.
Okay, let me just shortly introduce Shajay. Shajay is a senior associate at Zaha Hadid Architects, where he co-founded and heads the Computational and Design Research Group, the CH Code. His alumnus and studio master at the postgraduate course of Design Research Laboratory at the Architectural Association, the AADRL, exploring participatory systems of development of the built environment that are enabled by advances of digital technologies and design, digital technologies of design and manufacturing. Shajay pursues his interest in manufacturing and structurally informed design technologies as a PhD candidate at the Block Research Group in Zurich, and previously as an MPhil graduate from University of Bath, UK. Shajay has published in scientific journals and conferences along with contributions to architectural discourse through Architectural Design and other magazines. He routinely engages in public speaking at various professional and academic conferences, events, and institutions across the world. He is, for me and for many of our colleagues, most of our colleagues, I will say, a great mentor and a great source of inspiration in our careers. So I'm very honored to introduce him tonight. Without further ado, please welcome Shajay tonight.
Yeah, thanks a lot, Juan and Ale, for the introduction and the opportunity to speak here. And let me share my screen. Oh, disabled participant sharing.
Let me, sorry, 1 second. I'm just gonna give you the host. There you go.
Yeah, so thanks also to Martha and other organizers. I genuinely support these kind of efforts, as you can perhaps also see that Patrick also supports it, and Paolo. We try and make time for these efforts and initiatives, mostly because we are genuinely curious and also we know where we started, like similar. I mean, Patrick also started similarly, like several decades ago, and I for sure started maybe 15, 17 years ago in a similar situation. So any academic engagement, particularly with younger students, we're always keen to engage in. So I will just share my screen now.
Yeah. You have greetings from India, from Win Associates.
Well, do I get rid of this? Yeah.
You can see the screen now.
Yeah. Can you see?
Mhm.
Yeah. Yeah. So like perhaps Paolo did yesterday, I would like to take this opportunity to talk about some of the behind the scenes, or like and a journey that is several years long and many decades left to go. So um, and I'm going to talk mostly about like architectural geometry and how that is truly a something that builds on historic wisdoms in the built environment, and it's also a true platform for collaboration, like across architects, engineers, end users of the built environment, and hopefully how we as we see that this could lay the foundations for a truly disruptive architectural practice. Towards this end, I pursue most of this professionally as working as Audit Architects. I'm also learning. I'm doing my PhD in structurally informed geometry yeah, at the Block Research Group in ETH in Zurich. And I also engage with younger minds and nurture talent at the Design Research Lab at the Architectural Association in London. Um, so most of you, like, and particularly if you have seen Paolo's lecture yesterday, probably knows these architects for buildings like these, like the world's largest passenger terminal that attracts like 70,000 plus visitors a day, not people taking the flight, but just coming to see the building. Um, or this other building that completed also in 2019, the Soho Laser Tower with the world's largest atrium. What's interesting about these two buildings that completed very next to each other, and I feel very fortunate to have witnessed, is that like all the behind the scenes, like several innovations along many different dimensions, not only technologically but also legally. There's like a train station like literally underneath this tower, and all the building code regulation innovation that is needed, etc. But what I was very fortunate to witness at very early on in my career is that like these buildings, though they completed in 2019, the technological investments in them were started already in 2007, etc. Um, when Beijing had the Olympics in 2008. So that kind of already gave me an idea that, and also assured me, or at least gave me hope and inspiration that like Zahid architects was definitely an environment to nurture whatever wild ideas one might have. And so it kind of made me realize that like we should also pursue a seemingly funky idea, like and because at that time I was and very deeply interested in computer graphics and geometry and so on. I just I just didn't know how it would apply to architecture. So and to this date, like we continue to pursue that interest. And the other interest like was also like emerging technologies of that time. Like suddenly robots were being released from their automotive industry background, from the factories, and things were becoming more widely available, knowledge and also cheaper robots, etc. So these two occupations like kind of were just early days, and like we were genuinely interested, and like I was fortunate enough to be nurtured by Patrick and also Zaha at that time, to be able to found a group with very untested ideas. Like, and I definitely didn't have any background in geometry nor in robots. And to this day, I am quite amazed that like Patrick and Zaha took such a risk, that they started a group with me. And along the way, like around the same time, like this seminal book came about, which kind of combined both of these interests, and so-called architectural geometry, geometry that is structurally and fabrication-wise aware. So it knows how it stands up, and it knows how it can be made. And this was like quite a seminal book with like many outstanding contributions, and particularly Helmut Pottman, who kind of revolutionized this field. Uh, and since then, like we have discovered that this is not just restricted to one book, and like uh, several architectural researchers and professionals and institutions across the world are deeply engaged in this practice of linking geometry with architecture, um, and particularly architectural structure and how fabrication technologies. And there's also precedent to this, and the movie making industry is particularly something that we quite often follow keenly, precisely because there is this duality between, like, on the one hand, storytelling, like, which is what like all the end users are particularly caring for. Like if we go see a movie, we are only interested in looking at understanding the movie, what the characters are saying, what they're doing, etc. We often just forget that there are several PhDs worth of research going into any one movie. And the other interesting parallel with the movie industry and architecture is that it probably takes a similar amount of similar number of people, maybe 200-300 people across all professions, to make a big, reasonably large building as it takes to make a movie. So, and so we definitely aspire for this kind of technologically informed, but it's not technology takes a backseat. Like it's the storytelling that the technology supports. So in that sense, we see a lot of parallels with the computer graphics animation industry. And those of you in Spain, or particularly even if you're not from Spain, like these buildings, like, and this effort probably resonates. So there is architecture is a lot about storytelling on the one hand, which is technologically informed on the other. Like, so people like Gaudi and others were precisely able to focus on the storytelling and creation of user experience. Uh, uh, Mostly because they already inherited a large amount of scientific knowledge and techniques of calculating structure, techniques of calculating stone cutting, and all of this was pre-computer time. So it was all of these calculation methods were geometrically based. And that so and so that we see a deep influence of geometry as a collaborative and expressive language, so that the architects could then focus on the left side of this rather than only the right side. So and also geometry was then transmitted further through these methods of construction of shapes, manuals, like how to draw a specific shape step by step, which is very much similar to Grasshopper and like other techniques of today. There's like forums and like so on how to draw certain things. It's a similar pre-computer history of how to draw ellipse and how to draw a projection of something and so on. And what was interesting is that such a geometrical background really informed the entire building construction industry. Like the instruments already encoded such geometry, so there were specific instruments to draw certain kinds of shapes. And also this geometry became transmitted into the way drawings were drawn, how to make construction drawings in a specific way, how to make joinery details in a specific way, etc. So geometry was like the kind of underlying spine and the glue that was holding the entire industry from storytelling to construction. And so we see that this kind of history can definitely be beneficial for us in the computer age to learn from. And also like modernism itself like has done this before, like build based on the new technologies of the time. Bauhaus, even though it was a short-lived movement, like it had deep influences, like well into the century and perhaps even now, um, where like part of the curricula was exploring new methods of manufacturing, new techniques, new industries, things like weaving on the left, and also part of the curriculum in Bauhaus was like things like curved crease origami, or the curved version of origami. And so this we deeply inherit this kind of spirit of inquiry, where we explore technology and new methods of making and new forms of knowledge, and in the DRL and also at Zadid Architects. And like this kind of spirit obviously made its way and into the showcase buildings of the 70s, and in the spirit of the age just after the war, etc. So and further on, like it did definitely make its way into the housing and more mass buildings of the time, like public buildings, etc. So so this is what we genuinely are inspired by, like a kind of uh, technologically inspired, but like storytelling focused architecture. And so the first decade of our existence of our group, like we've been exploring new methods of making, and in new economies, like from the top left, where that is in India, to high tech making on the bottom right with robots. Uh, that we believe that geometry and exploration of these techniques are independent of economies of construction, which is something very much that we inherit from modernism. Um, and like after the first decade of that such experiment, like in currently we as a small team, like my team is maybe about 13 people now, and Zadid Architects is about 480 people. So you can see it's a very small team, but like the top two rows are projects that we are currently working on live, and altogether they total to more than 1 million square meters. And the bottom row is like projects that we worked on before, some of which are complete, others are going to be completed, etc. So there's a direct correlation between like experimentation on the one hand uh, and like how we are able to contribute to the growth of the company, and also maturing of all the experimentation into buildings. So, but at the same time, I'm going to talk mostly about like the period from zero to the first decade, where we just start with zero expertise or experience and totally being naive about what to do, but like believing fully that like everything is possible, and how we experimented, and incubated and invested a lot in understanding building collaborative networks, assimilating knowledge, such that we are now able to handle quite a large number of variety of projects, from master plan to stadiums to metro stations to other. Um, so, so we are currently three years into the second decade, where we are definitely applying and scaling whatever we learned in the first decade. But yeah, so I will talk mostly about decade zero and a little bit about decade one. So from the beginning, we've been like kind of fortunate and nurtured by Patrick and Zaha to have a project independent thinking. So we did do project independent research, and we continue to do that. And we kind of constantly rub it against reality by applying it or trying to apply it with special interest projects, small scale projects, like where we can truly experiment. And also we did a lot of we continue to do a lot of exhibitions, writing, public speaking, engagement with like workshops. Like I personally have done more than 50 workshops, like the one Ale is doing. And also we nurture talent both in-house and through our teaching externally as well. So this is what we do, and we continue to try and do. And in terms of talent development, like we found that like just landing in a strange economy and designing and building something in 10 to 15 days like really is the only way to really build talent, the soft skills and the hard skills, to think on our feet, to make do with like whatever is available. So for example, when we did this first one in India in 2010, all we had knew was that there was a tailor who could stitch fabric, and we sourced that person, and his shop was like maybe 1.5 meter by 1.5 meter, like just a square, which he had a sewing machine, and we bribed him to stitch this fabric. And these are the only drawings that we made. So we designed this with students, and we made these drawings, and one for bending pipe and the other for cutting fabric, and both of them like that was sufficient to make the installation, and the concrete was hand rendered, and the last set of drawings only for the foundational footing. um, and so and you can see that like really just permeates like with in a scaled version, like this is better engineered, better understood, better quality construction, but the principle is the same. Like you bend pipe and you stitch some fabric and stretch them, and then you have you have a building. And so that's that kind of intuition, like that that we understand. I mean, we didn't work on this particular project, but like it was around the same time. And you can see the similarity between doing experiment at a smaller scale, but it's real forces, real material, and that begins to also form the basis for teamwork and also collaboration of multiple kinds of skills. So much so that like two of my colleagues from the team, like they felt so, after a few years of working in the team, they felt so confident in working in these kind of uncertain ways that they decided to form a company to make robots, which they were not qualified to do because they were trained as architects. But at the same time, like because we approach everything from first principles, like there was nothing preventing them from doing so. So and now they're fairly successful mid levels, mid stage startup. And another colleague, like a few years later, also because of our interest in geometry and computer graphics, etc., like decided that he would pursue actual career in computer graphics as a software developer and researcher in a place called Double Negative that make support movies like Gravity and other places. And also, like part of the spirit of engagement and building this kind of collaborative team is working with other startups external to the company that who are also similarly minded, small scale. So this Odico Robotics was two architects and an engineer who went to who procured robots like when the economy was doing not so great in Detroit and other places. So they got robots for cheap, like so it was two architects and 5 robots or something. And 7 or 8 years later, now they're traded publicly traded company on the Nasdaq. So it's this spirit of like, engaging with like uncertainty, but like really seizing the opportunity as they come along, that truly interests us about this topic. And similarly, also AI Build, like that we collaborated with to make this 3D printing sculpture. They're also now like a reasonably maturing startup in London. Both of them worked uh, for Zadid for a while, and like and this particular sculpture is like a combination of like robotic hot wire cutting from Odico and 3D printing from AI Build. And similarly, also with concrete printing, like we are collaborating a lot with a young startup in Innsbruck, who are literally using a lot of the code that we developed like early on, uh, um, and now they're building on top of that like a lot of their production processes, such that like for me it's helpful, like when I'm doing a PhD, I can literally send them a file and they can print it. So it's a very collaborative environment, a very closely knit, dense network of people engaged in similar things and similar interests. And that's been maturing for well over a decade now. And in this context, like one of our long-standing partners and collaborators is the Block Research Group in Zurich, and Philippe Bloch, who's Professor Philippe Bloch is also my PhD advisor, and from them, like we genuinely share, we learn a lot about the structural use of geometry and how that is the first step, and perhaps the most important step to be materially effective, and also the first most important step towards sustainable building construction. Why? Because geometry helps you save a lot of material if it is designed appropriately, and on top of it, if it is designed appropriately, you can use weak material, which means that like you're saving on energy needed to make the material stronger. So this is typically to so you use less and you use less of already weak material. So and these two things together make geometry the key component, the key ingredient to make anything sustainable, and uh, and also expressive. And these are like the kind of techniques that like Gaudi were using, and like his contemporaries, and even prior to that, architects like Christopher Wren from the St. Paul's Cathedral here in London, etc. And so these techniques, because of their pre-computer time, like on the right side, those are the only diagrams you need to understand the structural stability of a spiral staircase, for example, which is entirely in compression. And visually it can tell you that the boundary edges correspond to these thicker lines, the forces, and so on. And then it helps correlate physical models, and when things fail, like you can look it up visually as to why that might have been the case, until it uh, actually works, right? And so this has been like a kind of continued affiliation and association with Block Research Group. Every day we learn something in collaboration and with them. And also this was recently featured on the BBC, that so-called architectural geometry from historic times. What can we learn about sustainable practice from ancient arched and vaulted designs? So it's not only nostalgia, and it's not only to be like historic. Like all of these things like are particularly relevant to the 21st century, and that's really our interest as Adid architects, is like how we can build on all of this knowledge and use new technologies and solve 21st century opportunities and issues of the built environment. So that's where architectural geometry and so-called tectonism really come hand in hand. And Patrick's perhaps will talk a lot more about tectonism on his lecture a week from now. And these techniques like are being commercialized into these kind of floor slab where, because of curvature at the bottom and because of the pattern of ribs on the top, it is about 70% lighter, and it saves a lot of space as well. So, and you can imagine when you multiply floor slabs in a building, this quickly adds up to a lot of savings. Um, and so all of this are how we maintain an agile collaborative network. And then all of these experiences we also assimilate into a geometry-based framework of code, computer code, and also a set of tools that we develop in-house and also in collaboration with Block Research Group and other researchers across the world. And these research topics, which are assimilated largely, are related to textiles fabrication, textile construction, and also sheet metal constructions and origami, and also high resolution polymer printing, large format 3D printing in bioplastics, and also 3D printing in concrete. So several, almost any, and several others, like any new fabrication technology, we try to understand geometrically and inform our architectural language through these processes of fabrication and construction. So our aesthetic is driven by the way it is made. So that's an essential feature of like the geometric expressions that we are trying to explore and pursue. Uh, how things stand up and how things are made are integral to how we pursue shape design. So that's, by now you probably get a good sense of what we mean by architectural geometry. It is basically structure and fabrication aware shapes. Shapes that are not arbitrary, they're historically informed by historic techniques, they're made suitable for contemporary and emerging commercializing technologies like 3D printing, hot wire cutting, sheet metal folding, etc. And so it kind of considers design and tools like in a holistic way, like from design to production, so to speak. It's not only design and expression, but all the way to how things will be made. And here you can be reminded of like how the computer graphics animation industry, like we originally mentioned, there is the storytelling aspect, but like obviously it still has to be simulated, and it still has to be drawn on the screen, etc. So there are like a lot of production constraints alongside the storytelling. And one pavilion example I can give you that's like kind of highlights this is this integrated design, engineering, construction, fabrication approach is Knit Candela. So is a collaboration with the Block Research Group and Architecture Extrapolated. And this sculpture was made 6 meters under the ground, and everything that was needed to make this came through that door on the back, that small door. That was the only method to get stuff in, only access to get stuff in, and it is 6 meters under the ground in a courtyard in a modernist building that like they wouldn't allow us to touch anything, let alone dig. So and the way and it was also a homage to Felix Candela, who was like perhaps one of the 20th century's pioneers and leading practitioners of architectural geometry. As you can see, shape that is clearly structurally beneficial, very little thin concrete that can support large amounts of weight because of its double curvature. And it is also construction aware because you can produce doubly curved geometries with simple straight lines, straight lined, ruled, meaning timber planks that will make the shape. And so once you can make the shape in timber planks, then you can cast it in concrete. But because of that, like it comes at a price, so you have to make the shape twice. So that's clearly problematic because you have to get rid of the timber after. Even though it is relatively easy to make, you're still wasting the formwork. So what this technology that the ETH and Block Research Group have developed, the so-called knitcrete technology. What it does is like get rid of the problem of the formwork by having this as a lost formwork. So it is knitted in fabric, and there's a cable net inside it, and you stretch cable net and then you cast concrete. So this was like Mariana's PhD research. Mariana is my colleague at like Block Research Group, and she basically knitted all of these several kilometers worth of knitting in like a small machine, which was then put in a suitcase and taken on air. She took it on in her cabin luggage, kind of, and then it was stretched in Mexico, and architecture extrapolated. Then like coordinated all the construction in Mexico, like with the boundary timber and the concreting. And so here again, concreting is a crucial skill, like which is like a skilled labor, which is very difficult to otherwise cast in these doubly curved ways. And so architecture extrapolated its previous experience and collaboration with Zaha Code really paid off here. So it's like really Block Research Group, Zaha Code and architecture extrapolated coming together, start to finish, with like 2.5 months, 6 meters under the ground, below grade, and designed in London, and co-designed and developed in Zurich, and constructed in fabricated and constructed in Mexico City. So and similar textile ideas like are permeating through our commercial, our first interior kind of project. Everything that you see here, like including how to cut the fabric and how to all these benches and all the lines on the ground, and all of these vitrines, etc., are made using similar logic of looking at fabrication, looking at structure from first principles point of view. And also this is allowing us freedoms to tell spatial stories. So one of the ideas was to make the gallery free at eye level for children, and it only breaks the eye level for adults. And also this is a small gallery. We didn't want to make several rooms to tell 25 different stories. The curator wanted to tell 25 different stories of everyday use of mathematics, like in trade and travel, use of in aeronautics, and in gambling, and etc. And so there was also some somber stories, like some personal, intimate stories, like relating to the use of mathematics in eugenics and other things. So we created these kind of pockets of space to tell those intimate stories, and like release them in larger pockets for more exuberant stories. So there is like a deep storytelling aspect afforded by this kind of language, whilst we can also construct it rationally. And so these pipes are designed so that they can be bent. These seam layouts are considered where to put them so that like the fabric doesn't stretch and wrinkle, etc. So there's both sides of construction, but also storytelling. As you can see here, like, so there's spatial effects that we explore, like how can you create pockets of space and release them, etc. And also work with tailors and engineers, etc., to come up with a stitching pattern that works both spatially and also can be works in terms of stitching, in terms of tailoring. And also similar, like while we were doing that, like we were also able to then do this other project, like which is for a school for refugee children, again, start to finish through 2 months. And it uses literally the same principle of textiles and like a thick boundary profile. And it comes flat packed, and it opens up like a book, and that automatically stretches the fabric, and then creates this kind of creates this space for children. This was like a prototype school, which was supposed to be deployed throughout the region, which unfortunately didn't happen for political reasons. But yeah, like it's regardless of like whether it is in high tech areas or low tech areas, like the geometry is independent of the budget, so to speak. And another topic that like is similarly we're very much interested in is like this idea of curved origami or curved crease folding. It's similar to straight rigid origami, straight line origami, except that instead of folding across straight lines, we fold across curved lines. So the logic is the same. And this also has been taught like for a long time. It has a long history, like from Japanese art, etc. And in the modern day, it was taught in the Bauhaus as part of the curricula by Joseph Albers. And also it's picked up by artists and mathematicians alike, like Eric and Marty Demain are a father and son pair. One of them is a genius mathematician, other is an artist, sculptor. And again here, people like David Hoffman, who is a mathematician and did origami on the side as a hobby, but he made like several contributions to creation of these kind of exquisite shapes. And artist Ron Resch, who deeply influenced engineers like Chuck Hoberman and others. So, and recently, like a lot of computational interest in how to recreate these physical patterns geometrically and on the computer. So people like Helmut Popman and others have been contributing to a lot of sorry. Yeah, contributing to a lot of computer graphics methods and algorithms, etc., on how to. And for us as designers, what this means is like it's so intuitive to physically do this. Like you cut some paper and score some paper and score some curves, and then you apply some force and you get curvature for free. And on top of it, you get variety for free, like small changes in how you cut paper and which holes you make. You get an entire family, and this is very useful as designers. Like you explore a world of possible shapes which are still fabricatable, which are still you can make them. And so when we made this in India, we had to go find a laser cutter, and like obviously there's no digital fabrication companies like readily advertised in places like India. But like where we found the laser cutter was a person who was cutting license plates for cars. So we made a deal with him that like we write a script for which will make his life easier, and like he should cut this like kind of at like cost. So within a few hours, he was able to cut all of this, and with the help of students, we were just able to fold and make each of these eggs in a matter of a few hours each. So, and like a few thousand pounds, like less than 1,000 pounds or something. Like so, it's quite uh, so it's quite revealing how like if things are clear geometrically, like you can literally make them in many different ways in many different economies. So that's and also like there's a 2D 3D relationship. This is how you discover. You crumple paper and then you try and draw the pattern and then draw it cleanly, and then you can create all these kind of complex shapes just from a 2D pattern, right? Like so so there's like a deep rationality to the way these shapes are formed. And also what works at smaller scale is typically scalable at least like 3 to 5x bigger, right? That's another big advantage of like this kind of geometry based thinking, that it scales well. And that's how we also did this sculpture in 2012 for the Venice Biennale. Like we figured out that all the simple tools that we needed to write and program ourselves, like to make sure everything is unfoldable, such that a robot can like do the reverse process, take the unfolded shape and fold it back to the original 3D shape. Uh, and again here, like the intelligence is in the shape and in the geometry. The robot is actually quite dumb. It doesn't even know that like we put some metal on its way. It just happens to be bending it because it thinks it's following a path. So there's no great intelligence in the robot, but the process has a lot of inherited intelligence. So and you can see this is almost real time. Like very quickly you can make a panel, and there were 400 such panels to be made, and it's 6 meters tall, 1.5 millimeter thin aluminum, just held together because of this curvature. And most of them were made by the robot, but like some we had to bend by hand. And when we went into this, like we had no idea of origami, no idea of robots, but because it was a geometry based way to understand, uh, it was relatively easy to put together, or we were confident enough to put together some kind of workflow to make it happen. So we didn't study like a large amount of mathematics or anything to make this happen. And similar story with hot wire cutting and these benches. They were we again looking at like historic techniques of like stone cutting, how to lay stones in a specific pattern to save to be structurally effective, and also how to cut like these stones from one single block of stone using so-called ruled surfaces, right? Like straight line cuts through to produce curvature. And so it's a similar logic, just extended. Instead of stone, we use foam, and instead of like chiseling, we use the wire. And so you start with the full block on the bottom right, and like several cuts later, you end up with the foam bench, which was then cast in ultra high performance concrete, and then produced. So again, here we're using arches to save material, and some of these benches are 4 meters long, and there were 16 benches made on time, on budget, and also a unique aesthetic coming from the way it is made. Like these sharp lines are because of the foam, and because of the hot wire, you get this very sharp crease, and also very smooth finish. Because it's the wire, there's no milling, like it's just a very smooth finish that you just finish with concrete. So again, aesthetic and structural performance and fabrication considered all together. Similar story with like 3D printing of this sculpture, uh, where we combine hot wire cutting to make the form work. Again, the base shape is made of ruled lines, straight lines, so that like you can cut them into pieces using a hot wire. And then subsequently, because the printer doesn't want to start and stop, like we just abstracted this physical principle of keep pushing wire into a constrained space, and it naturally makes this uh, curved, curly shapes within a constrained boundary. And we did that on a 3D surface. And you can also notice that we densified along the boundary where we want more stiffness, and it's less dense where there's less structural forces. So that's the general idea again of structure and fabrication. Like it's 7 kilometers of like wire 3D printed in 6 or 7 parts as the drum rotates and the robot prints like this, and then you assemble. Again, like it was like not very long, like maybe start to finish was like about 2 months. Again, not knowing so much about printing before we went into making this kind of experiment with AI build and Odicom. So I think like that perhaps gives you an idea that like in a kind of whistle stop tour, very fast paced tour of like the first 10 years, how it quickly evaporated for us. But it has been deeply scientific. There's a lot of learning that we did by reading other people's work, collaborating with like smarter people. and collaborating with artists and collaborating with scientists, etc. And so it's been very exciting, and a lot of fun. And as you've noticed, like, it has been very entrepreneurship friendly. Like, lots of our colleagues and friends like started companies, either in related fields or in robotic fabrication or geometry creation, etc. And also, unlike modernism, it's very historically continuous. Like, it is not like modernism throwing away the baby and the bathwater. Like, we are learning, standing on the shoulders of giants, and extending and enhancing all of that knowledge through the use of computers. So it's very historically continuous, and also is ecologically or at least the first step to be ecologically sustainable is creating appropriate shapes. Um, and so it's not like surprising that like we are now able to really scale this to Main Street Futures with like a lot of contributions to stadiums, metro stations, mixed use towers, like this one we're currently working on in China, or handling this almost like small little city, like or it is a city, and several other projects simultaneously for a small team, which I think is should highlights the benefits of like thinking in an integrated architecture storytelling way, but also ahead of time thinking about how it's going to be made, how it's going to structurally stand up, etc. Um, so I will end with like this, like one project that is very dear to us, like is how we translate all of these into making it available to a wider public. So we are working on topics of prefabricated building components and also combining it with game technologies for end user participation. So we're in our work in the DRL, we are exploring through students and more blue sky thinking, how we can customize, we can combine these customization technologies where the robot doesn't care if you make one beam slightly different from the other, and make it useful for the end user. So either combine it with mass customization, particularly in the housing domain. So some of our students have been exploring this in the DRL, how we can combine these technologies of 3D printing or hot wire cutting, floor slabs and beams and columns, etc., and combine them with like truly customizable space, and help use game engines to work, uh, provide choice to the end user. So not one size needs to fit everybody, or every community can kind of customize their own housing requirements and so on. And also we can then construct it economically subsequently. So, and literally that's we're trying to use these exact same principles in the first pilot Zadi project in Honduras, where we built like a where we are working with Circular Factory and Architecture Extrapolated again, to import these robots and to build something much bigger than the robots using local material and timber. Uh, and on the other hand, like we also built this software layer, which allows for people to choose their houses, where they want to place them in a grid, and also how to customize the interiors, etc. So for example, they can choose these 3 pixels or those 3 pixels. And once they made those choice, like we automatically calculate all these variety of outcomes. And then all of those are already pre-configured to be buildable. And that gives us also an idea of how much time it takes to convert raw material into the house. So just a little glimpse into what we are working on, how to take this decade of work and interest and make it available to the wider public in terms of housing. So with that, I will leave you here And thank you for your attention.
Thank you, Shajay.
Yeah.
Thank you for the amazing lecture. It was, yeah, I don't know. I'm gonna try to take some questions from YouTube and questions from the students, but perhaps like I could just throw you a short question to begin with.
Yeah.
Yeah, like maybe like if you could elaborate a bit more about like to start the Q&A on the very beginning of Saga code, CH code, and let's say like how it was the very first year and the initial steps. Like if it was very clear for you that you will be exploring architectural geometry and robotic fabrication and so on, or if you had like some other ideas to begin with.
Yeah, no, there like nothing was clear except that like that the office would support like the effort, right? Like, and Patrick and Zaha would definitely support like experimentation and support like exploration of like new things in a sincere way, as long as it is sincere and based on first principles, ask the right people and develop a network. And so there was like a it was, I mean, I didn't even know there was anything like robotic manufacturing or that there's architectural geometry and these kind of things. It just, because I was interested in computer graphics, that was clear. And like I just happened to find all the people who are doing anything related to that. And then in a meandering way, like over many years, like we discovered like all the right people. Like as I said, like one of the longest standing collaborators has been Philip Bloch and the Bloch Research Group, but also other engineers like in Arup and in AKT, in Bureau Happels, particularly with this, and also startups, as I mentioned, like Odico with Yele and Asbjorn. And like, so, we're all part of like sharing similar interests and exploring possibilities. So, and I think that's why, like, I truly believe it's a collaborative
Mhm.
effort. And on top of it, it is a cumulative effort, right? It's not like you invent something every Monday morning, as Mises would say.
Mhm.
It is a long effort, and we are very much enthused that like within the first decade of like us being engaged in this, like we're already seeing the first buildings, like in not
Mhm.
only in like places like Europe and US, but like mostly also in China, places like India, Latin America, like where they're literally leapfrogging over uh, uh, where there's ready application for these things as well. So where there's a need, and also we are now trying to make it available in game engines and so on. Like, so you know, um, yeah. So nothing was clear, but like along the way, like we just made the right friends, and yeah. So, and it's always been rewarding. It's not like we had to wait 10 years to be rewarded. From the very
Mhm.
first things that we did, it was rewarding because it was new, and we were discovering things. I mean, to this day we discover every day something, right? Like, so
Mhm.
that's why it's engaging.
I think something that it was always super interesting for me was like the like like all the pavilions and experimentations you've done as well, like in Mexico and India, like with very low budget, like very kind of low tech technology, and
Yeah.
still achieving like interesting shapes. I don't know if any of the students wants to ask any question. You wanna drop it on the chat, or if you wanna directly ask here in Zoom, and then Marta will also throw here if there is any question from YouTube. I'm sure there are some questions.
Well, if anybody has a question, I would like to ask you one. It's related to virtual reality and the work that you're recently doing. I've seen one that was truly amazing. So, how do you see using these technologies into maybe into the urban space to make the normal user make them see them useful for them? Thank you.
Yeah, sure. I think like of course, like like as the research matures, I mean not only ours, like but mostly the more fundamental foundational research in robotic fabrication, digital geometry creation, etc. Like when that is maturing, these kind of participatory mechanisms become uh, extra useful. Like so, I mean, one of the advantage of like these kind of shapes, which are construction wise informed and also structurally informed, is that um, that they can be easily created in non CAD environments, meaning they can be created outside of Rhino, or they can be created outside of Maya. Like they can be, I mean, Maya in itself is not a CAD environment anyway. So, so that's one huge advantage, that like, like there's an entire new generation that are growing up digitally natively, growing up on Minecraft and growing up on Fortnite and growing up on Roblox. Um, I mean, so if these shapes can be made available there, for sure, like that there will be new skills and new mechanisms to participate. So that's one. And then there's also game engines have one critical feature that architectural software doesn't. That is the representation of a user. So a user exists, can be represented in a game. So games naturally have the idea of avatar. They naturally have idea of some human person that like you have to input you see the world through this view of the person or multiple people, right? Like, and so that's uh, so combining these two, like, on the one hand, there's like a lot of emerging technologies of construction, which is rapidly commercializing, and we know it is like ecologically better, and technologies of mass customization. And then you combine that with participation, and for sure, we see a very positive outcome. And like I cannot talk more about this project, but this is our first pilot project, a real world project, where we are trying to combine not only robotic fabrication but and local material, etc., but also user choice, right? Like, so people are literally choosing their house where they want to pick place it, etc. So we do definitely see a very bright future from a participatory angle for um, these things of customizing, because particularly when it comes to houses, like every house should be different, and nobody wants their house to be exactly like the neighbor's house, right? So
we have a question. We have a few questions from YouTube, Shajay.
yeah.
So the first question, it kind of mentions that you have lots of fabrications aware design methods inspired by, it says nostalgic, I guess, like it's like more like a historical reference.
Yeah.
And then the question, it's more related on how do you kind of take those concepts and convert, or like, let's say, like expand with the new technologies and like hire the new challenges of our century. So basically, like, how do you take like a historical reference and kind of like have your own take on it?
Yeah, sorry. Yes, I mean, this is a very good question and an important one. Is that it's not the work of individual architects, right? That so it's not that like, as one person you can have an idea and like take it all the way
Mhm.
from historical reference and then like designing with it, etc. And so one thing to notice here is that it is definitely collaborative. You need to be participating in a community, and in fact, like that's how architecture has been for the most part. Like even
Mhm.
Gaudi, like as celebrated as an architect as he is, as a lone mystical architect, like Sagrada Familia is not only because of Gaudi, right? He assembled the right team
Yeah, exactly.
on the first of all. Like he was very protective of like the masons and like very supportive of them and so on, and also inherited a large amount of knowledge of how to design, how to track the center of gravity, and like design in a structurally sensible way, because otherwise like tons of stone is going to fall on somebody's head. So um, yeah, so it is not a single person or a single company, or you have to be participating in a collaborative community,
Mhm.
and which is very true and very much possible now through technology, right? Like through Grasshopper forums,
Mhm.
and also tons of people are making their research available, like you know grasshopper, I mean like kangaroo or something, like now everybody can like at least begin to dabble and explore like initially, and then like they get access to more scientific research coming from Block Research Group or Stuttgart, or like even more people like Chris Williams and others, like who designed with Foster and Partners the British Museum roof. Like when I started, like that seemed like magic to me. Like how is how is it even possible? Um, and but now like a lot of that code and a lot of that knowledge is available on online and in forums and in papers, in publications. I mean, the amount of free information that's available is like incredible. So as long as you participate in a peer group, and also participate in a historically continuous research trajectory, uh, you will build up the necessary mindset and also have access to the necessary tools to engage with historic ideas and also new construction
Mhm.
technologies.
Uh, I think we have Fernando here, one of the students. Like, Fernando, you want to ask the question directly?
Oh, actually, on that point, I would like to make a shout out to Compass, which is a collaborative open source
Mhm.
learning environment, so-called didactic as well. So, and it's the kind of brainchild and baby of like one of my PhD advisors, Tom, along with Philippe from the
Okay.
Block Research Group. So, and the other is also look out for workshops from my colleagues at Zaha and Zaha Code.
Mhm.
Yeah, sorry, Ale, what was the other question?
No, well, I don't know, Fernando, you're here? You want to ask the
Yes,
question? Yeah.
I would like to actually ask, what do you think about how is going to the technology is going to develop this architectural future? Because in the last, I think, 5 years, there has been such a huge step forward in this aspect of the architecture. So I don't know if in the next, for example, 5 years is going to be developed even faster than it has been.
Um, yeah, definitely. I mean, there's every hope to be optimistic, right? I mean, every reason to be optimistic. And I mean, personally, I'm very enthused and optimistic about as challenging as the environment that we live in is. Like, I mean, of course, we're in the middle of a pandemic, and And also, there's increasing challenges facing humanity, but like I am very enthused that like we will innovate out of it. So there's now the knowledge is available, increasing amounts of knowledge is available. There's a necessity to innovate climatically and socially and so on. And so we have the means and the motive and the opportunity. So definitely, like we can we should feel that like we should see some dramatic change in the next coming years for sure. And like a large part of that is also like perhaps like people like you and us wanting to make that change happen.
Shajay, maybe connecting to this question. So let's say like after, I guess it's like plus 10 years, like 10 plus, like, I don't know, 10, 11, 15 years of experience, like with cutting edge technology, all the kind of like novel design projects that you've been participating. If you could tell us a little bit more about your most challenging project, and then also if you could comment on your next goals and challenges.
Well, I mean, I think the most challenging is always the first one to take the first step. And so perhaps like the leap of faith that I made was to leave my job in a different company and join Zaha. So unlike most of my colleagues, I didn't join Zaha right out of school because I didn't know much about Zaha Architects, to be very frank. And I wasn't even sure of like whether I will do the DRL master's program in the first place. So so once I made those leaps of faith, like everything else is subsiding into discoveries, and I think yeah, like so. And what's been most rewarding is that like accidentally I seem to meet people of who go on to become significant in the field, and also before I came to the DRL, I didn't know Patrick or I didn't even know about the DRL, and I'm grateful for the mentorship, but also like sincere collaboration in many cases with Philippe and also Theo, for example, like the director of the Design Research Lab, like uh, like people like these are building communities and building the right spirit of inquiry. And that I think is contributing to those communities, and that kind of spirit is the most challenging, but also the most rewarding. So it's not necessarily related to one project, but the meta project, let's say, of building technical and creative capital to make these to make a change to have an impact on the built environment.
And the next ones, the next goals and challenges?
Yeah, that remains the main motivation to have an impact on the built environment, and so that's why we're immediately working on the kind of participatory mechanisms, using game engines and combining that with this fabrication and structural design technologies. Yeah, so that's so it's aligned with the longer trajectory of having some kind of impact on the built environment.
So there is here another question from YouTube. They want to ask you about AI. What do you think about AI, and whether you think that it will take a role in? So do you think it's going to take the role of an architect in a form finding process, and how do you think it's impacting the industry?
Yeah, I mean, we see several uses of AI, and AI in a kind of discover. I mean, one of the most interesting things for us as AI is in a discovery process, right? That so particularly in this game engine kind of way, once we set up a game, we can use AI to play the game in thousands of millions of times, similar to AlphaGo or AlphaZero, that rediscovered learned to play chess, and it turns out that like it learned to play chess in a very human way. Like a lot of grandmasters were remarking on like how amazingly non-computer like that gameplay was. It was taking risk, and it was doing very unbelievably elegant ways that humans might do, not like in a robotic kind of brute force way. So that's like a big carrot for us, like to use AI to understand human intuition, understand human history and human behavior and so on. Like, so that discovery process is genuinely one of the most interesting uses of AI that we see. And will AI replace architects? Like, it doesn't seem likely. And more so, it doesn't seem necessary, right? Like that. I mean, in the end, like everything that we do is for our own intellectual curiosity and also solving our problems. So yeah, so as long as that remains, like I don't see AI ever replacing architects. It's like any other technology is going to augment our skills, like the phone, in this sense. Like we believe a lot in like the kind of uh, thinking and mindset of Andy Clark and the idea of an augmented cyborg, right? Like we use our phones to extend and augment our capacities. For example, already we do that. So yeah, so AI is just a next step. It's like having 1,000 brains to do certain things better than the human brain. But yeah, but it's always going to be enhancing and augmenting,
more enhancing.
so that we can pursue our curiosities and solve like human-made problems, right?
Maybe we can wrap it up with this last question from YouTube. So yeah, I think like it's a good question also to wrap up the session. Sure. It's whether you could give like which kind of advice would you give to architectural students for their future careers? The classic one.
Yes, take risk and genuinely form collaborative efforts, like look beyond Instagram, look beyond form deeper relations and deeper knowledge streams, and think. I mean, the best advice, like Brett Steele, like the then director of AA, once gave me was to think in decades. And I think Patrick also said something like that in different ways. So when you're starting, like think in decades, not in days or not in years. So yeah, that's what I would say.
Step by step.
And so you be cumulative, be collaborative. That would be my advice.
Okay, thank you, Shajay. Thank you so much for thank you so much for being here tonight with us. Yeah,
you're welcome.
Hope everyone enjoyed it. Yeah, we'll see everyone next Sunday for Patrick's lecture, and we'll see you for the jury, Shajay.
Yes,
thank you so much, Shajay.
Thank you.
Yeah, thanks a lot.
Thank you very much.
Good luck with everybody.
Thank you.
Thank you.
Thank you.